This is the table of contents of our presentation slide. We start with introduction, literature review, methodology, result and discussion, and the last is the conclusion.
The next will be project background of our project. At the heart of this automated line is a programmable logic controller PLC, a large industry computer designed to withstand demanding environments like excessive vibration, temperature fluctuations, and electrical noise. It effectively replaces complex and inflexible hardware relay systems and is programmed using the intuitive ladder logic language to manage critical control functions such as sequencing, timing, counting, and safety interlocking. This project demonstrates mechatronic system integration by seamlessly combining three distinct operations: a food sorting system, a food quality control system, and a food packaging and sealing system into one cohesive automated production line all under the central command of the PLC. The entire system operates on a continuous and automated PLC cycle. In the sensing part, the cycle will begin as various sensors, including those for color, metal detection, weight, and proximity, feed real-time input data into the PLC. The next will be computing. The PLC internal program, written as a ladder diagram, then processes these inputs, executes pre-programmed logic decisions, and determines the necessary actions. For the actuation, finally based on this decision, the PLC triggers specific outputs such as solenoid waves, conveyor motors, and alarms to control the physical process, thereby completing the automated loop. Next will be the problem statement of our project. Our current reliance on manual and semi-automated processes leads to unacceptably slow production speeds and high operational costs. Furthermore, a critical lack of integration between the mixing, seasoning, and packaging stage creates persistent bottlenecks and costly delays. These are some critical quality control issues. The absence of real-time monitoring allows for undetected defects such as underweight bags and dangerous metal contaminants to reach the market. This is compounded by inconsistent seasoning application and unreliable packaging seals which directly compromise product quality and erode customer satisfaction. The core problem is in exists the absence of on-the-field automated system is fundamentally hindering our efficiency, product consistency, and operational safety. To resolve this, we propose to design or implement a fully integrated PLC-based mechatronic system that provides seamless automated control from the initial sorting stage all the way through to the final packaging. Our objective of this project will be to design a PLC-based circuit diagram that integrates the food sorting, quality control, and packaging and sealing system into a single coordinating operation. It is also to enhance overall operational efficiency, safety, and product consistency by automating the packaging process, thereby minimizing human error and ensuring standardized high-quality output. Next will be the scope of our project. We will create a complete PLC control system detailed with full circuit diagrams and ladder logic programming to integrate the three core subsystems into a unfilled production line. This integrated line will consist of a quality control system for metal detection and weight verification, a packaging and sealing system for automating bag sealing, and a color-based sorting system to categorize different flavors such as blue, red, green. Next will be the component selection. This phase will involve specifying an appropriate PLC model to serve as the system brain, selecting all critical sensors including metal detectors, weight sensor, and color sensors, and choosing the necessary actuators such as solenoid valves, conveyor motors, the sealing heater, and labeling machinery. Before the deployment, we will test the complete system logic using a PLC simulation platform to verify a proper sequencing, interlocking, and timer operations, ensuring the entire process is robust and error-free.
So moving on to the literature review. Firstly, I will explain regarding the food packaging and sealing system. So this packaging plays an important role in a savory snack productions because it protects the snack from physical damage as well as exposure to moisture, oxygen, and also light. This situation is essential to maintain the crunchiness, the freshness, and also the overall shelf life of the product. So in this section, a major concern is the seal integrity because if the seal is not properly formed, oxygen can enter the packet, causing the snack to lose its crispiness or even can be spoiled. So, in this packaging system, we must ensure a strong and consistent seal as part of this packaging system. So, and last but not least, nowadays, modern snack factories use automated system such as form fill seal and so vertical form fill seals machines. So this system form the pouch to fill the product and also seal it continuously, which will help reduce the manual handling and lower the risk of contamination with humans. So overall, automated packaging ensure higher speeds, better consistency, and also will improve the product safety. So moving on to the food sorting system. So in a multi-flavor production line, each snack flavor use different packaging colors. And because of that, a color-based sorting process is required to ensure that each flavor is grouped correctly before boxing. So this help to prevent mix up, especially when there is multiple flavors run on the same line. Next, the automated sorting provides several benefits, such as the system can route each pack to the correct line automatically, which reduces the need of manual labor and significantly cutting down human error. And it also will increase the efficiency and ensures consistent product assurance. And last but not least, the sorting system will works using a vision based approach where a camera captures image of the package and the image processing algorithm will classify them based on their color in a real-time data. So overall, this allow the conveyor system to sort each pack accurately and quickly. And finally, about the food packaging quality control system. So one of the most important checks in packaged snacks is its weight control because every pack must comply with food labeling regulations. So if a pack is underweight, it will become a legal issue, and if it's overweight, it will increase the production cost. So this is why weight checking is considered as critical control point in packaging. So in this system, we will be using load cell for weight measurement. So a load cell works by converting the mechanical force into electrical signal. So it will be using a strain gauge weight stone bridge mechanism where a tiny deformation caused by the weight change will the electrical resistance will produce a millivolt output. So this will allow a very accurate detection of the actual weight of each pack. And finally, this contributes to overall product assurance, where accurate weight checking ensures that all pack will meet the 50-gram requirement, reduce the material waste, and also prevent unnecessary giveaway. And lastly, it strengthens the regulatory compliance. So combined with the sorting, sealing system, and the load cell checks, it will help to create a fully automated and reliable packaging line.
So moving on to methodology, I will be explaining the flowchart first. So let us look at the flowchart from our group here, where we have 4 steps, which is sealing process, quality control process, labeling process, and also color-based sorting process. So for step 1, which is sealing process, where the process begins when the conveyor belt moves package forward, and the system first checks if the package has been properly sealed. If not sealed, then the capacitive proximity sensor confirms the packet arrives under the sealing clamp. The conveyor belt will stop, and also the sealing clamps engages and applies heat for a set duration for around 5 seconds to melt and fuse the package opening. Once the timer completes, the clamp releases and the sealed package advances. For step 2, quality control for weight verification, the sensors are activated and input from the load cell measures the packet weight. This is where the quality control happens. The system checks, is the packet weight 50 plus minus grams? If yes, then the package passes the quality check and receive a pass label. If no, meaning it is underfilled or overfilled, which the system activates a timer for 2 seconds, then the pneumatic pusher rejects the package, which remove it from the main production line. And from the step 3, which is labeling process, the packages that pass quality control automatically receive a pass label stamp onto them to ensure clear identification of approved products for traceability. For the last step, which is color-based sorting, where finally the system detects the packaging color, which represents different snack flavors. And based on the color detection, if the package is red, then the timer 1 seconds activates and the red pneumatic pusher directs it to the red product line. If the package is blue, then timer for 2 seconds activates and the blue pneumatic pusher directs it to the blue product line. And if the package is green, then the timer 3 seconds activates and the green pneumatic pusher directs it to the green product line. If none of the above, then the package would be yellow. And as the overall of the flowchart here, this fully automated system ensures consistent product quality through integrated sealing, weight verification, labeling, and color-based sorting. It minimizes human error, increases production efficiency, and guarantees consumer safety.
Alright, so first up we have the packaging and sealing system, which is our first system in our production line, whereby it consists of 4 components, which are the push button, the capacitive proximity sensor, the conveyor belt system, and the clamp itself. Now, obviously, for the push button, it is obviously to start and stop the packaging and sealing systems of the conveyor belt. Now, in the second one, we have the capacitive proximity sensor, whereby it has 2 functions. Firstly, it is to detect the location of the food packages on the belt itself. And secondly, it is to detect the clamp hand position, whereby whether it is in a, let's say, in a clamp position or in an unclamp mode. And thirdly, we have the conveyor system itself, where it consists of the belt, where it is used to transport the food packages, the sealed food packages. And then lastly, we have the clamp itself, whereby it is to clamp the packets opening and heat them to seal it. Now that is for the packaging system. We'll move on to the next system. Now, the second system, we have the quality control system, whereby we have 6 different components. Firstly, we have the detection head, whereby it has an opening that allows food products to pass through for inspection. Now, secondly, we have similar to the first system, we have the conveyor system, where we have the belt, which is used to transport the package and seal food packages. Now, thirdly, we have the load cell, whereby it measures the package's weight, and also we have set it about around about 50 grams plus minus. Now, secondly, we have the pneumatic pusher, whereby it acts as a rejection mechanism, whether the packages are underfilled or overfilled. So that means this load cell and also the pneumatic pusher works in tandem. Now, there is one other unit, which is called the control unit, that works together with these 2 components, whereby it processes the signals received from the load cell, and it receives the weight measurement and will interpret them. So that means from the load cell, it will measure the weight. Control unit receives that information, and then the pneumatic pusher will act as a response mechanism. That means whether it is unfilled or what is underfilled or overfilled based on information obtained from the control unit. Now, lastly, we have the user interface, whereby it allows operators to set detection parameters, adjust of weight limits, and also monitor the number of accepted and rejected amount of products that is produced. Now, for the label and stamping system, which is the third one, we have 2 components, which is the capacitive proximity sensor, which is used to detect the arrival of our savory snack products that has been passed through the quality control system. Now, the second component, which is the pneumatic cylinder, this is where the real work of the label stamping system gets done. Now, the product that goes through and passed through the quality control system will then be provided the force necessary to stamp the pass label onto the surface. So this functions is conducted by the pneumatic cylinder. So that means the pneumatic cylinder will act as will provide the force necessary to put the pass label onto the product which has been passed through the quality control system. Now, in the last part of our system, in our production line, we have the flavor sorting system, whereby we have 4 different flavors corresponding to 4 different colors. Now, first of all, we have the pneumatic pusher, which is a transfer mechanism to push the red, green, and yellow into other conveyor belts. That means it will push the red, green, and yellow products into other conveyor belts, as it means for different flavors. Now, this is why we are doing the flavor sorting system, because we want to sort the flavors according to its colors. Now, secondly, we have the compressor, whereby it supplies air towards the pneumatic pusher mechanism. Now, pneumatic, we know pneumatic is something to do with air, so we have to, let's say, supply air towards the pneumatic pusher. So we have the compressor to supply to function that. Now, next we have the photoelectric sensor, as previously learned in class. It is to recognize the color of the food packages. We have green, we have blue, we have red, and also we have yellow, which represents the different flavors of our products. Now, fourthly, we have the conveyor belt, which is as usual to transfer the item from one section to another, whereas its movement is actually being controlled by a motor. And lastly, so how we supply the compressor to how we supply air in terms of to the other components is by using connecting pipes, where it connects all the components in a system that uses the compressed air. So that is it for all the systems and all the components in our subsystem of our production line.
Moving on to the ladder diagram simulation. So when we start the operation by pushing the start button, the belt motor will turn on and move the conveyor belt. Even after we stop pushing the start button, the belt will be keep on moving due to this latching here. So when the packet arrives, it will detected by this packet arrive sensor. So it will activate this clamp motor. After this clamp motor is fully clamped, it will detected by this clamp position sensor and activated the heater. So after 5 seconds, the heater will turn off due to this timer and turn on unclamp movement by the clamp, and also turning on the auto move to allows the belt to move again. Next to the quality check system, the packaging weight will be detected by the weight sensor here. So assuming the pusher is in retract position, if the packet is more or less than 50 gram, it will extend the pusher, and after 1 second, the pusher will be retracted to its original position. So for example, the weight sensor is turned on, will turn on the pusher, it will extend the pusher, and after 1 second, the pusher will be retract. So after the packaging pass the QC check, the packaging will be detected by this pass sensor. So we turn on this, and the stamping action will be started. As for example, the stamping will be extended, and for 2 seconds, the stamp will be on the packaging to set the package, and after 2 seconds, the stamping will be resetted back to its original position, as you can see here. Now moving on to the flavor sorting system. When the packet arrives at the sorting system, the packet will be sorted according to its color. So if the packet is in red color, red sensor will detect its presence and will initiate 1 second timer. Assuming the packet will arrive at the pneumatic pusher after 1 second. Same goes to blue packet. If the packaging is in blue color, the blue sensor will detect it. And after 2 seconds, the pneumatic pusher will push the blue packaging into different conveyor belt. Same goes to green color packaging, only that its timer is after 3 seconds. And for yellow packaging, yellow sensor will detect its presence. However, it will not activate any of the timer, so the packaging will stays on the same conveyor line for its sorting. So here, for example, we activate red sensor, and as you can see here, the pneumatic pusher is turned on and turned off, so it extend and retract quickly. Same goes to blue packaging. When we turn on the blue sensor, it will extend and retract after 2 seconds. And for green packaging, it will extend and retract after 3 seconds, as you can see here.
So for the step one, we have the packaging and sealing system, whereby we'll be explaining how many rungs there is and what each rungs represent. But before that, as explained before, there are 4 different systems. So that means we have the packaging and sealing system, we have the quality control system, we have the label stamping system, and finally we have the flavor sorting system. Now, first off, we have the initiation, whereby the process actually begins when the operator starts or presses the start push button, which initiates the system and also activates the belt motor. Now, this allows the conveyor to transport our incoming packages towards the sealing station. Now, the system remains running while in auto mode, creating a stable and also continuous workflow. Now for package detection, for which is the second one, as the packages move along the conveyor, the packet's arrive sensor detects when a package has reached the sealing zone. Now, once detected, the system triggers the clamp motor, initiating the closing motion of the sealing clamp. Now, this ensures that each package is properly positioned before heat is applied and clamping begins. Now, clamp position verification, which is the rung three. Now, the clamp position sensor monitors whether the sealing clamp has successfully reached the fully closed position. Now, when the clamp is positioned to be fully engaged, the system activates the sealer timer, initiating the control heat cycle required for proper sealing of our products. Now, fourth, we have the heat application. Now, the heater is energized once the sealer timer begins its countdown. The system applies consistent heat to the upper position of our package for a duration of time corresponding to our time period. Now, the timers, which are normally close contact, ensures that heat is applied only during the designated sealing window. Now, once the timer completes, meaning the time has finished, the normally closed contact will open up, automatically stopping the heater. Now, fifth, we have the clamp release and also the conveyor advancement, whereby after heating is complete, the sealing clamp retracts to the unclamped position, and simultaneously at the same time, the auto move sensor confirms that the package is ready for the next move on, the next step, and will reactivate the belt motor, allowing the conveyor to advance the freshly sealed package to the next step of our production line. Now, sixth, we have the system reset. Now, the system reset and preparation for next stage involves whereby the absence of the package triggers the two things: packet arrive sensor and also the clamp position sensor to reset their state. So once the packages has been, let's say, is not in position anymore, these two sensors will automatically reset to their original state. So this resets at the same time the heating timer and returns the entire sealing mechanism to its original ready state. So which at the same time makes the whole entire system ready for the next system or the next, let's say, flow of products. Now, seventh, we have, and the final one, we have the continuous operation cycle, whereby the entire sequence, starting from the package arrival and also the departure of the package, which includes the package release, repeats continuously if the system remains in auto mode. Now, this automation ensures a steady flow of our products, consistent sealing quality, and also minimal operator intervention.
So for step 2, which is quality control process, step 2 is our automatic quality control system using weight verification. As next packages move along the conveyor, each one passes through our weighing station where a precision load cell measures its mass instantly. If a package is underfilled or overfilled, which falling outside our target weight range, which is 50 plus minus gram, the system immediately activates a pneumatic pusher to separate it from the production line. The pusher then extends and holds the rejected package for 2 seconds to ensure it's completely isolated and removed safely. And once the timer expires, the pusher retracts automatically to reset the system for next incoming package. This automated weight-based quality control ensures only corrected filled snacks package continue to labeling, sorting, and maintaining consistent product quality and preventing defective items from reaching customer. And for step 3 is our label stepping system, which marks all quality approved packages for traceability. Only packages that have successfully passed our weight verification to continue to this stage. When a package is confirmed to meet our specifications by both the pass sensor and the weight sensor, the system activates the stamping extender, positioning the stamping tool directly above the package. And a timer then engages for 2 seconds, which hold the stepping head in place to ensure the label is clearly and securely applied to the package surface. This precise timing guarantees consistent, professional marking on every approved package. And once the timer 2 seconds expires, the stamping tool automatically retracts and reset the system for the next incoming package. And this automated labeling process provides clear identification for inventory tracking and ensures only quality assured products are marked for distribution to customer.
Next, I will explain the last step, which is the flavor sorting system, step 4. In this step, packages of different color, red, blue, green and yellow are automatically detected and sorted into their respective conveyor path using photoelectric sensor, timers and pneumatic pusher. For red packaging, when a red package passes the photoelectric sensor, the sensor will activate 1 second timer. This delay assumes the package needs 1 second before it reaches the red pusher. Once the timer finishes, the red pusher extends and pushes the package into the red conveyor line. After that, the pusher retracts to its original position, ready for the next package. For blue packages, the system works similarly, but with a 2-second timer. The sensor detects the blue package, waits for 2 seconds for the package to arrive to the pusher, then the blue pusher extends, sorting the package into the blue conveyor path. After pushing, the pusher automatically retracts. For green package has the longest delay, which are 3 seconds, based on the distance and the speed of the conveyor. After 3 seconds, the green pusher extends and sorts the package into the green line. It then retracts like the other. And finally, for yellow packages are treated differently. The sensor will detect them, but no timer is activated and no pushers are engaged. This means yellow packages continue straight onto the main conveyor belt without being diverted.
In conclusion, all project objectives were successfully achieved with the design of a fully integrated PLC-based automation system. This solution seamlessly combines the core subsystem, food sorting, quality control, and packaging and sealing into a single coordinated operation. By automating the entire process, the system directly enhances operational efficiency and product consistency, effectively minimizing human error and ensuring standardized, high-quality outputs. This unified mechatronic solution successfully replaced fragmented manual processing, utilizing advanced sensing and a real-time PLC control to guarantee consistent quality and reduce reliance on manual intervention. This project delivers a viable blueprint for a high-speed, reliable, and intelligent automatic packaging line, thereby fulfilling the core objective of superior product assurance.